So in this video, we're going to talk about how we actually use the unit circle to find the exact values of a bunch of different trig functions. So I have pulled in here the unit circle. So again, you can print one off of Canvas, you can Google, you can find them. They're very easy to find. And then over here, we have all the things we're going to look at. But before we do that, a couple things. So remember, when we do the unit circle, all of these values on the unit circle, they came from triangles, right? So if I look at this pi over 3 part here, this really came from a reference triangle that looked like this. And in that reference triangle, the radius was 1, the x value here is 1/2, and the y value here is √3/2. And so if we think about it, remember we said, if we think about the basic trig values, we said that the sine of an angle was equal to y over r. We said that the cosine of an angle is equal to x over r, and that the tangent is y over x because it's opposite over adjacent. The thing to remember is on the unit circle, right? So this is, again, to drive home, this is the unit circle. On the unit circle, r is always 1. So on the unit circle, it's only on the unit circle, the sine of theta is equal to the y value, and the cosine of theta is equal to the x value. So generally it's y over r, x over r, but on the unit circle only, we can kind of simplify this a little bit. So that's going to help us out on these problems. Okay, so let me erase what I wrote here, my triangle, so that now we can look at these. Okay, so my first problem here says the sine of 180 degrees. So I'm going to find 180 degrees. So here's 180 degrees. The sine, so sine is the y value. We're going to look here at my point. So the y value here at my point is 0. So the sine of 180 degrees is 0. The cosine of 315 degrees. So I'm going to find 315 degrees. The cosine is the x value. The x value is √2/2. So this is going to be √2/2. Secant, right? So if sine of theta is y, cosine of theta is x, we could just write the rest of these down here too, right? So tangent of theta we said is y over x, and then we would flip them over, right? So for the cosecant of theta, it's going to be 1 over y. The secant of theta is going to be 1 over x, and the cotangent of theta is going to be x over y, just so we have them written there. Okay, so the secant of minus 315 degrees. So 315 degrees is here, but that's positive, right? So remember, positive angles swing this way. So a negative angle is going to swing the same amount, but in the opposite direction. So so this angle here, negative 315, it is going to go, so I'm going negative 90, another negative 90, so that's negative 180, another negative 90, that's negative 270, and then I need to go 45 more, which is going to bring us onto this spike here. So the secant of negative 315, so secant, right, if I come down here and look, secant is 1 over x, so the secant is going to be 1 over √2/2. And so we don't like fractions within fractions, so we do need to fix that. So remember, we're going to do keep, change, flip. So keep the first fraction, change the multiplication, flip the second fraction. So 2 over √2. So this would end up being 2 over √2. So that's kind of how to do that problem. So let's see, let me erase off of keep my unit circle here clean. Okay, so tangent of 270 degrees. So here's 270 degrees. Tangent is the y value over the x value. So this would be the y value which is negative 1, over the x value, which is 0. Now, hopefully we all remember that you cannot divide by 0, right? So we can't do that, which means we actually can't find the tangent of 270. It's actually undefined. So we actually don't know what it is. So let's see, a couple more here. Sine of 11 pi over 6. So here's 11 pi over 6. Sine corresponds to the y value. So the sine is just going to be minus 1/2. The secant of 2 pi over 3. Right? So here is 2 pi over 3. Secant is 1 over x. Right? So it's going to be, the secant 2 pi over 3 is going to be 1 over the x value, which is minus 1/2 is the x value. So 1 over minus 1/2. And again, keep, change, flip. Keep, multiply, times negative 2 over 1. So it's just going to turn out to be negative 2. We have the cotangent of pi over 2. So here's pi over 2. Cotangent is x over y. So in this case, that's going to be 0 over 1. Now, 0 over 1 is allowed. 0 over 1 is 0, right? So I think about, when I try to remember which one is what, I think about, this is just me, I call it pizza math. So if I have no pizza and one friend over, how much pizza is everybody getting? None. Here, if I have one pizza and no friends, nobody is in the room, how did it get there? It doesn't make sense. So that's why it's undefined. So that's my little trick. But basically, you want to remember that a 0 on the top is okay. A 0 on the bottom is not. Okay, now my last 3 examples. Sine of 15 pi over 4, tangent of 17 pi over 3, cosecant of 16 pi over 3. All of these values here, if you look over on the unit circle, they are not on here someplace. So we need to actually find them. So we need to find an angle on the unit circle that is coterminal with this angle 15 pi over 4. Now, you could go back to what we did before with coterminal angles and all that stuff, but I personally just think it's easier to count it off. So if we think about looking at the pi over 4 spikes, so this here we're starting at 0, we have 0 pi over 4s. Then here we have 1 pi over 4. We move by 45 degrees, right? So pi over 4s are moving 45 degrees. If I move another 45 degrees, I end up at this spike, which even though it's written as pi over 2, that's really the same as 2 pi over 4. So it's still really a pi over 4. Then I have this spike, which is 3 pi over 4. This spike, which is 4 pi over 4, which you would notice the 4's cancel and I get pi. I have here 5 pi over 4. This would be 6 pi over 4, which is the same as 3 pi over 2 if I reduced. 7 pi over 4, and then I'm back to this spike here. So I'm looking for 15 pi over 4. So all I have to do is count off 15 of these spikes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 pi over 4 brings me to the same place as 3 pi over 2. Okay, wait a minute. I didn't count that right. So let's try that again. So this, we're starting here, that's 0, right? 0 pi over 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, now we ended in the right place. So 15 pi over 4s is this spike here. And the sine is the same as the y value. So it's just going to be minus root 2 over 2. So we can do the same thing if we're looking at the next two problems, which are both pi over 3's. So if I take the pi over 3's, pi over 3 spike is 60 degrees. So we have 1 pi over 3. Here's 2 pi over 3. This part here, if I jump another 60 degrees, so 3 pi over 3, which is just pi. Then I have here 4 pi over 3's, 5 pi over 3's, and then here 6 pi over 3 is the same as 2 pi. Okay, so we're looking for 17 pi over 3. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 pi over 3's. So we're down here. So our tangent, we're going to take the tangent of this. Tangent is y over x. So it's going to be, it's going to be the y value minus root 3 over 2 over the x value, which is 1/2. And again, if I multiply that, let me pull this problem here down a little bit so we have a little bit more room. So if I multiply that, if I flip that, so it's going to be minus root 3 over 2, change the multiplication, flip my fraction over, 2 over 1, cancel those out, and you get minus square root of 3. And then my last one, so again, if I'm looking for 16 pi over 3's, they happen to be the same as the orange ones. So again, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 pi over 3's is here. Cosecant is if you look down here, cosecant is 1 over y. So we're talking about 1 over, and the y value here, let me erase it a little bit so you can see. So the y value here is minus root 3 over 2. So it's going to be 1 times 2 over minus root 3, or minus 2 over root 3. And you could do a similar thing with pi over 6's. So if you were doing the pi over 6 spokes, just so you kind of see it, pi over 6 is 30 degrees, so that would be here. It would also overlap with the pi over 3, and then here. So basically you're splitting each one of these into 3 pieces. So the pi over 6 spokes pretty much take up everything except those 4 pi over 4 spokes. So just so you're kind of aware, you would use those pink ones that I just put up there if you were doing if you had something that you were doing with pi over 6's.